Lesson 6-2, writing linear equations in point slope and standard forms. And in this lesson, you learn to write linear equations in point slope form and to write linear equations in standard form. Why is it important? Because you can write linear equations to solve problems about geometry, involving geometry. So if you lived in Miami, Florida, moved to Denver, Colorado, what adjustments do you think you might have to make? Obviously, the weather is different. But did you know that you would also have to adjust to living at a higher altitude? As the altitude increases, the oxygen in the air decreases. This can affect your breathing and cause dizziness, headache, insomnia, and loss of appetite. Over time, people who move to higher elevations experience acclimatization, or the process of getting accustomed to the new climate. Their bodies develop more red blood cells to carry oxygen to the muscles. Generally, long-term acclimatization to an altitude of 7,000 feet takes about 2 weeks. After that, it takes 1 week for each additional 2,000 feet of altitude. The graph at the right shows the acclimatization for altitudes greater than 7,000 feet right here. Okay, so we can use any 2 points on the graph to find the slope of a line. For example, we'll use 9,003 and 11,004 to represent x sub 1, y sub 1, and x sub 2, y sub 2, respectively. Okay, so we use the slope formula, and we substitute the values of y sub 2, y sub 1, and x sub 2, x sub 1. We end up with a slope of 1 over 2,000. So let's suppose that we get a point in that line, okay, and we name it xy, okay, and it represents any other point on that line. We can use the slope and one of the given ordered pairs to write an equation from that line, and this is what we learned in the last lesson as well. So we substitute the value for slope, which is 1 over 2,000 is equal to y minus 3 all over x minus 9,000, because we represent x sub 1, y sub 1 as 9,003, and x sub 2, y sub 2 as x and y, the point on our line. Okay? And if we multiply both sides by x minus 9,000, we end up with 1 over 2,000 times x minus 9,000 equals y minus 3, multiplying both sides by x minus 9,000. Okay, and using reflexive property of equality, we have y minus 3 equals 1 over 2,000 times x minus 9,000. It's basically the same thing. The reflexive property of equality just switches the expressions on both sides of the equation. Okay, so what do we know? What did we learn from that? Since this form of the equation was generated using the coordinates of a known point and the slope of a line, it is called the point slope form. So we've just generated the point slope form, and the definition of a point slope form equation is that for any given point x sub 1, y sub 1 on a non-vertical line, non-vertical because when you say a vertical line, you'll have an undefined slope. Okay, so on a non-vertical line having a slope of m, the point slope form of a linear equation is as follows. So y minus y sub 1 is equal to m times x minus x sub 1. Okay, so you can write an equation in point slope form for a graph of any non-vertical line if you know the slope of a line and the coordinates of a point on that line. Let's see how this is applied in example 1. Write the point slope form of an equation for each line. A line that passes through negative 5, 3 and has a slope of negative 3/4. So we write down the formula. Y minus y sub 1 equals m times x minus x sub 1. That's the point slope form. And then we substitute the values. Okay, don't mind this x. I don't know why that's there. Okay, so we substitute the values now. So y, oh, before we do that, okay, let me redo that. Let's label our point. So let me do that again. Let's label our point, and let's make this x sub 1, make this y sub 1. And after we substitute x sub 1 and y sub 1 and the slope, this is how it will look like. So y minus 5 is equal to negative 3/4 times the quantity m minus negative 3, close quantity. Okay, so if we simplify m minus negative 3, that'll become m plus 3. So you'll end up with y minus 5 equals negative 3/4 times x plus 3. Okay, and that is now, okay, the equation of this line, okay, which passes through negative 3, negative 5, and 3, and has a slope of negative 3/4. Okay, let's take a look at example B. Example B, a horizontal line that passes through negative 6, 2. What do we know about the horizontal line? Our horizontal line has a slope of 0. So this is what we want to find the equation for this line. And since the slope is 0, we write down the formula for point slope form, and then substitute the values now, right here, right there. Okay, why is it not appearing? Let me just take this out so it will appear. There it is. Okay, we substitute y sub 2 as 2, slope is 0, then x minus quantity minus 6, minus negative 6, I'm sorry, close quantity. So we end up with y minus 2 equals 0, because anything multiplied with 0 will always be 0. Okay, and we simplify that to become y equals 2. So the equation of that line is y equals 2. Now you ask yourself, how about vertical lines? Well, we have an answer to that too. So a vertical line has a slope that is undefined, so you cannot use the point slope form of an equation. However, you can write an equation of a vertical line by using coordinates of that points through which it passes. Suppose the line passes through 3, 5, and 3, negative 2. Okay, something like this. If you have a vertical line which passes through points 3, 5, and 3, negative 2, all you need to do is find the x coordinate, and that will be the equation of your vertical line. So the equation of the line is x equals 3, since the x coordinate of every point is on the line. Sorry, let me repeat that. Since the x coordinate of every point on the line is 3. So if you have a vertical line, simply find the x coordinate, and that would be the equation of your vertical line. Let's move to standard form. Any linear equation can also be expressed in the form of ax plus by equals c, where a, b, and c are integers and a and b are not both 0. This is called the standard form of a linear equation. Okay, and the definition is here. The standard form of a linear equation is ax plus by equals c, where a, b, and c are integers, and a is greater than or equal to 0. Well, that means that a should be positive and not should be equal to 0, and not equal to 0. And a and b are both not are not both 0. Okay, so let's take a look at how this is applied in example number 2. Linear equations that are written in point slope form can be rewritten in standard form. So write y plus 5 equals negative 5/4 times the quantity x minus 2 in standard form. Okay, so we want to put it in the form of ax plus by equals c. And let's see how we do it. So first and foremost, we want to get rid of that fraction. But before we do that, let's copy the problem. And then we want to get rid of the fraction by multiplying both sides by 4. Okay, so you end up with 4 times the quantity y plus 5 is equal to 4 times the quantity negative 5/4 times the quantity x minus 2. Simplifying that, we have using the distributive property 4y plus 20 is equal to negative 5x plus 10. Because the 4 cancels out, you distribute negative 5 to x and negative 5 to 2. Okay, and then we want to get rid of one of our constants, so we subtract both sides by 20, and we end up with 4y equals negative 5x minus 10, and we want to put it in our standard form, so we add 5x to both sides. Now we have it in standard form, 5x plus 4y equals negative 10. That is the standard form of that equation. Okay, let's take a look at example number 3. You can write an equation of a line if you know the coordinates of the 2 points. Okay, if you look at example number 3, write the point slope form and the standard form of an equation of the line that passes through negative 8, 3, and 4, 5. So we have this line, it passes through those 2 points, and we want to find the equation of that line in standard and point slope form. Okay, so let's start. First and foremost, in trying to determine an equation of any line, you need to find the slope. And that means you need to know the slope formula again. And as a review, slope formula is y sub 2 over y sub 1 all over x sub 2 minus x sub 1. Okay? And using these 2 points, this is our slope. We're using negative 8, 3 as our x sub 1, y sub 1, y sub 1. So we have 5 minus 3 all over 4 minus negative 8, or our slope would be 1/6. Our slope, okay, is 1/6. So you can use either point for x sub 1, y sub 1 in the point slope form, and that's exactly what we're going to do. So in method 1, we're going to use 8, negative 3, and in method 2, we're going to use 4, 5. Let's go back to method 1 using negative 8, 3 as our x sub 1, y sub 1 using point slope form. We now have y minus 3 is equal to 1/6 times x minus negative 8. Okay, simplify x minus negative 8. You end up with y minus 3 is equal to 1/6 times x plus 8. Okay, and in method 2, since it's straightforward, they're both positive, simply substitute the slope and x sub 1, y sub 1. You have y minus 5 is equal to 1/6 times x minus 4. Okay, so both y minus 3 equals 1/6 times x plus 8 and y minus 5 is equal to 1/6 times the quantity x minus 4 are valid equations for the point slope form of an equation of a line passing through negative 8, 3, and 4, 5. So now let's find the standard form of each equation. So these are both acceptable point slope forms. Okay, these are both acceptable point slope forms, okay, of an equation for this particular line. Now let's use standard form. We're going to skip this because this is exactly a copy of method 1, method 2. I just I think pasted it twice. See? Okay, so we're skipping that. We're jumping over here. So let's find the standard form of those equations. Okay, method 1, we're using that equation, and method 2, we're using the second equation. Okay, so let's in method 1, we multiply both sides by 6 to get rid of the r fraction. So we end up with 6y. Okay, right here, 6y minus 18 equals x plus 8, because 6 times 1, 6 will give you 1. So you're left with x plus 8. Add 18 to both sides, you end up with 6y equals x plus 26. Subtract x to both sides, you end up with negative x plus 6y equals 26. Remember, standard form is ax plus by equals c, where a should be greater than or equal to 0. So it should be positive, and it should not equal to, it should be positive. Let's just put it that way. So what do? We multiply both sides by negative 1. We end up with x minus 6 equals negative 26. And this is a standard form for this particular equation that was in point slope form. Let's look at method 2. Let's use the other equation. And then again, we multiply both sides by 6 to get rid of our fraction. Then we end up with 6y minus 30 equals x minus 4. And then we get rid of negative 30 by adding 30 to both sides. And then we subtract x to both sides. If you notice, it's the same banana, different boat. Okay? So after you simplify the point slope form of that equation, okay, you end up with the same standard form. Okay? So regardless of which point was used to find the point slope form, the standard form of the equation, when all common factors are removed, always results in the same equation. Which also brings us to another point, that any line, any linear equation, will have its own unique equation, okay, especially standard form. So let's take a look at the last example. Write the equations of the lines containing the sides of a parallelogram ABCD in point slope form and standard forms. Okay, so we want to find the equation of the lines. We want to write the equation of the lines containing the sides of this particular parallelogram. So what do we know about this parallelogram? We have two horizontal lines. Okay, so since lines containing A, B, and CD are horizontal, we know that their slopes are 0. Okay, so the equation of side AB or line AB, y equals 3 right here, and the equation of CD is y equals negative 1. Okay, we know this by I think example 2. Okay, when we found the point slope form of a horizontal line. Let's just review how we got y equals 3. Okay, so if you look at line AB right here, okay, and point slope form is y minus y sub 1 is equal to m times x minus x sub 1. So if we substitute the values, so let's use this point 6,3. Okay, so if we use 6,3, this will be y minus 3 is equal to m times x minus 6. And since, I'm sorry, let me substitute right away. Okay, so let's substitute this to 0. So y minus 3 equals 0, or y equals 3. And that's how we got that. Okay, and you're going to be doing the same thing for line CD to find negative 1. Okay, so now use the coordinates of the points to find the slopes and equations of the lines containing the other two sides. So the other two sides are more challenging because they're not horizontal, and we need to find slopes for both of them. So use a equals negative 1, 3, okay, and d equals negative 3, negative 1 to find the slope of, okay, side AD. AD is right there. Okay, so if we do that, we first find the slope using the slope formula, end up with a slope of 4 over 2, or simply 2. Okay, and then let's use negative 1, 3 for x sub 1, y sub 1 to be able to find the equation in point slope form. Substituting the values for this particular point slope formula, y minus 3 is equal to 2 times quantity x minus negative 1. That's our x sub 1, y sub 1. And you end up with y minus 3 equals 2 times the quantity x plus 1. Okay, and putting it in standard form. Okay, we distribute 2 to x plus 1 using the distributive property. This becomes now y minus 3 is equal to 2x plus 2. Okay, undoing negative 3 by adding 3 to both sides, you end up with y equals 2x plus 5, and subtract 2x to both sides, you now have negative 2x plus y equals negative 5. Okay, so basically this particular thing skipped a step. It should be negative 2x, okay, plus y equals negative 5. And since you want to make this positive, okay, you have to multiply both sides by negative 1, and that's how you got this particular standard form equation. Okay, so let's use the other one. We will use 6, 3 and 4, negative 1 to find the slope of side BC. Again, using the formula for slope, end up find the slope of 4 over 2, or 2, since they are, what do you notice? they are parallel to each other. Those two sides are parallel to each other, and that should give you a hint of our next lesson. So if they're parallel to each other, okay, that means they have the same slope. So let's use B6, 3 for x sub 1, y sub 1. Easiest ordered pair to use would be all positives, because you don't have to deal with multiplying a negative with a negative. So you end up with using the formula for point slope form, substituting the values, you now have y minus 3 is equal to 2 times x minus 6, okay? And that would be your point slope form. And let's make that standard form. So y minus 2 times x minus 6, distributive property, y minus 3 is equal to 2x minus 12. Adding 3 to both sides, y equals 2x minus 9. And subtracting 2x to both sides and multiplying by negative 1. So what happens here is this. You're going to subtract 2x to both sides. You're going to end up with negative 2x plus y equals negative 1. And then you are going to multiply both sides by negative 1 right there. Okay, and this is what you're going to get. 2x minus y equals 9. Now, if you notice, okay, at this point in the game, okay, the book is actually deleting some of the steps because it is assuming that you know how to do the steps, okay? And the equation of the lines containing the sides of the parallelogram are y equals 3, y equals negative 1, 2x minus y, 2x minus y equals negative 5, and 2x minus y equals 9. Okay, and the key word for this particular lesson would be parallel. The word is parallel. That's a secret word. Okay, thank you for watching.